สวัสดีครับ M6 students how are you doing I hope everything going well in your holiday but in any way we have to keep going on our study definitely as what I have already mentioned from last week this week I have to give you a talk about Millikan oil drop experiment. Yes, now you have already learned from chemistry, but in physics we will learn more, and I think for the story about the discovery of the elementary charge and also the experimental setup, I think it's quite interesting for you as well. Are you ready? So let's get started. Go back to the problem about the discovery of the electron by J.J. Thomson. Do you still remember the experiment about the cathode ray tube? Now, I will try to talk briefly. By balancing the force from the electric field and the force from the magnetic field, Thomson he was able to calculate the ratio between the charge and the mass of the cathode ray particle. However, he found that even though he tried to change the type of the metal or he tried to change the type of the gas in the tube, in any way he got the same value for the ratio between the charge and the mass of the cathode ray from all substances. And finally, he got the conclusion that all substances must have the same elementary particle as the particle that you have seen from the cathode ray tube, and this particle finally is called electron, right? And from this discovery about the electron, you see, Thomson he didn't discover about the charge of the electron or he didn't discover about the mass of the electron, but he just discovered the ratio between the charge and the mass, right? And you see, if you are able to calculate the charge, you will be able to calculate the mass of the electron automatically. And therefore, from this problem about you know only the ratio but you don't know the single value of the charge or the single value of the mass, most of the scientists they try to invest time on the experiment how to calculate the charge of the electron or the mass of the electron. One of an interesting attempt how to find the charge of the electron was performed by one of a student of J.J. Thomson. His name is Charles Wilson, and he used the closed container. And from the experiment by Charles Wilson, in this container there is a supersaturated vapor inside this closed chamber, and this closed chamber is called Wilson cloud chamber. For the purpose of this design, at the beginning, Wilson he tried to use this container for tracking the motion of the charged particle. For example, he have to put the positive ion or the negative ion inside this chamber, and as you can see from the video clip that I have already put in the slide, you see that we can use the saturated vapor for the tracking for the motion of the charged particle. However, you know that the water is the polar molecule, and this polar molecule can interact with the positive and negative ion, and therefore there is no surprise that the ion inside the cloud chamber can act like a center of the condensation, or roughly speaking, if you just put the ion for a while in the cloud chamber, finally the water will be condensed and the center of the condensation is located at the positive charge and the negative charge. So from this observation, when Wilson tried to discuss with J.J. Thomson he realized that from this observation he can balance the force between the gravitational force or the weight of the droplet, and he balanced this force by using the force from the electric field. And by balancing this one and this one, we should be able to calculate the charge of the negative charge, or in this experiment, the charge of the negative charge should refer to the charge of the electron, right? This idea is very good, but in practical, you see that because of the type of the vapor inside this chamber. In Wilson experiment, he used water, and you know that for the water, it can easily evaporate, and therefore for the balance between the force from the electric field and the force of the gravitational force, you see that this force is not constant because water can evaporate, and therefore Thomson and Wilson they were not successful for the calculation of the charge of the electron. This problem about the fast evaporation of the water was revealed by Robert A. Millikan, one of an American physicist. At the beginning, Millikan he was not able to solve this problem. Therefore, he tried to set this problem as the topic of the PhD thesis and assigned this work to one of his PhD students. His name is Harvey Fletcher. From this PhD thesis, Harvey Fletcher and Millikan they worked together, and from this work they tried to change the substance from water into oil, because they know that in some type of the oil, some type of the oil they cannot evaporate easily. When they select or when they change the substance from the water into the oil, you see, our droplet have more stability, and when our droplet have more stability, it's quite easy for them to balance the gravitational force, which finally this gravitational force is constant, and they try to balance the gravitational force against the force from the electric field. And finally, they were succeeded in the calculation of the elementary charge. However, when they tried to publish this work, Millikan he published this work without the name of his PhD student, and also for the Nobel Prize as well. There is no name of the PhD student, and therefore for Harvey Fletcher that is unfair treatment by his PhD advisor. But in any way, Harvey Fletcher he was very gentleman. He tried to keep this feeling, and after the death of his advisor, he published a paper about his contribution on this work. If you are interested for the story between Harvey Fletcher and Robert Millikan, who is the first person who claimed that we should use the oil droplet instead of the water droplet, or who was the designer of this experiment. If you are interested, you can read by yourself. However, if you just look this experiment, you see that we have a big container, right? And if you look at one side of the container, you see the telescope for watching the oil droplet, right? How does the oil look like? So you may have no idea. So now Teacher Smart he has already recorded the motion of the oil in this experiment from our experimental device in KV. Are you ready? Let's see how the oil moves in the electric field. So This is one of the examples for the observation from Millikan oil drop experiment. So let's take a look closer. I have some questions to ask you. When you see the motion of the oil drops, did you see the oil drop at rest? Did you? The second question, when you see the motion of the oil drops, which direction are they going? Mostly, they are going downward or they are going upward. And the last question, you see, in this video, you see the scale, right? And for the magnification factor of the telescope, which kind of data that you can obtain from this observation? So I asked you 3 minutes for thinking, and after 3 minutes just come back and check your answer together. So please stop the video for 3 minutes. How about your solution? For the first question, you see, most of the drop, they are going upward, right? And when they are going upward, now, from your observational video clip, you see, now you hardly see the drop is at rest, and therefore, when the drop is moving into the air, now you have to consider the air resistance for the motion of the oil drop. That is one thing that I want you to keep in your mind. The motion of the oil drop in the air is mean that you have to consider air resistance from Stokes law. And second, now you see, now all of the drop or most of the drop, they are going upward. Now, however, you observe by using telescope, right? And you know that from the observation by telescope, you will get the inverted image, and it means that actually the oil drop, they are falling down or they are going downward, and therefore you see the image that going upward like this. And for the last question, which data that you can get from this observation, you see the scale in the eyepiece of the telescope, right? And second, you also can count the time from the video frame rate. And from this thing, it means that you are able to calculate the rising time and the falling time. However, this motion of the oil drop, they are moving in the air, and in this experiment, Harvey Fletcher and Millikan, they assume that all of the drop, they move with the constant velocity due to the terminal velocity that you have already learned from the fluid mechanics. And therefore, when they move with the constant velocity, it means that when you know the rising time and when you know the falling time, you should be able to calculate the rising velocity or the falling velocity. And from this observation, you are able just only to calculate the rising velocity or falling velocity. So let's take a look closer for the experimental setup.